pick up where we left off yesterday and look at standard form. Our standard talks about picking out key features in standard form, and we're looking at wanting to graph this line that is x minus 2y equals 6. That equation, we want to graph it on the graph. And I gave you a hint. One of the key features, one of the things that's really handy about standard form is we can simply use the x and y intercepts to graph a line, especially if it's in standard form. Here's what we know. We talked about it yesterday that the y-intercept, remember if we talked about y equals mx plus b, the y-intercept is where x is 0 and y is whatever value it is. Also, the x-intercept, we gave that a little a yesterday, is where y is 0. We talked about that yesterday in class. So what we want to look at is we're going to take this standard equation and we're going to find the y-intercept. Now, the standard form here is x minus 2y equals 6. And if I want to find the y-intercept, then all I do is substitute in a 0 for x. All right, so if I put a 0 in here, okay, so I'm trying to find the y-intercept, so that x value of 0 goes in right there. Well, 0 minus 2y, it's just 0, right? I mean, this part here, so we're just left with the minus 2y part. I can write it down if you want me to. It's 0 minus 2y equals 6, but I don't need the 0. Don't worry about that. But I am, to figure out my y-intercept, going to divide by -2. I'm just solving a really super simple equation. And so it's y is equal to -3.
And where does the 0 come from?
Okay, where the 0 came from is the y-intercept. I made a big deal about that yesterday, if you remember. The y-intercept always has an x of 0. Okay, and the other side is true too. The x-intercept always has a y of 0. Okay, so when it crosses that axis, the other coordinate is 0. Has to be. There's no way it can cross that.
So that x will always be 0?
When we're finding the y-intercept, x is always 0. Always. Okay? So to find it using standard form, I just plug a 0 in for x. Solve this real simple question, equation, -2y equals 6.
When you find the y-intercept?
When I'm finding the y-intercept, yes. So I found, when I solved it, that y is equal to -3. So my y-intercept here is -3. Let's find the x-intercept. I'll change colors. That'll be a little clearer for us. X-intercept then is where y is 0, right? So if I I'll take this same equation and I say, well, x minus 2 times 0, because I'm plugging in now a y of 0, equals 6. Okay, so now I've inserted the 0 because I know at y, x is 0, right? So what is x minus, well, 2 times 0 is 0. So what's x minus 0? It's just x, right? So when I multiply by 0, that term basically drops out. And there's nothing to do to even solve that. My x-intercept is at 6. Because all I did was plug in a y of 0. 2 times 0 just drops out because x minus 0 is 6. So it's solved automatically for me, really. So my x-intercept, I'm going to give that the little a, is positive 6. So when I go to graph it, all I have to do to graph this is to graph the x-intercept and then to also graph the y-intercept, which is -3. Okay? So remember, to graph an equation, I really need 2 points. So the graph of that line then is through those 2 points. A perfectly straight line. So all I have to do to find the graph, to graph the line, is to find those x and y intercepts. And all I have to do is substitute a 0 for the other coordinate. Let's look at another example. Let's graph this line. Okay, so I want to find the x-intercept, and I want to find the y-intercept. I'm going to start with y. I don't know why, I just am going to. So to find the y-intercept, what do I plug in for x if I'm finding the y-intercept?
0.
0, sure. So 2 times 0 here, okay, I can write that down. Okay, 2 times 0 is 0. So I have 3y equals 8. I divide by 3, and so y is equal to 8 divided by 3. Now, it'd been nice if it had divided evenly and worked out perfectly, but it didn't. 8 won't divide by 3, so I'm just going to leave that. You know, it's helpful to know what kind of improper, that's an improper fraction, what kind of mixed number that is. 3 will go into 8 2 times, which is 6. All right, and I'll have a remainder of 2, so that converts to be the mixed number of 2 2/3. How do I do that? Well, all I have to remember is that the fraction bar means to divide. So I just said 8 divided by 3 is 2, remainder of 2. The remainder always goes right there. It's always in my numerator, and my denominator will not change. Let's determine what my x-intercept is then. So that's 2x plus 3y equals 8. This time I'm going to put in a 0 for my y-coordinate to find the x-intercept. So 3 times 0 is 0, so I have 2x equals 8. But 3 times 0 is 0, just drops out. Divide both sides by 2. So x is equal to 4. So my x-intercept is 4. My y-intercept is the point 2 and 2/3. So it's going to be approximately right there. So all I did was I went up to 2 and I kind of estimated what 2/3 was between 2 and 3. And then I just have to graph those 2 points. Oops, missed. There we go. A perfect straight line. So because of standard form, because of the x and y intercepts, it kind of makes graphing a little bit easier too. That's something we can take advantage of. Okay, so we've got a line. And we want to write the equation of this line in standard form. All right, so I have a y-intercept, don't I? What's my y-intercept? Well, this is marked by 2, so my y-intercept then is a -2. Point value here is 0, -2. And this point is +2, 4. So I can take that and find my slope real easily. All right, so I move over 2 places. I'll make a run of 2. That'll be a rise of 2, 4, 6. So I'll make a run of 2. And I have a rise of 6. My line is going uphill left to right. It's positive. 2, 4, 6 here. I really should reduce that 6 over 2 to be 3 over 2. Reduce that fraction. And so if I want to write it in standard form and I have a slope and I have a y-intercept, that's where I start. Okay? So it is y. Oh, by the way, which form will I use? If I have a slope and a y-intercept, I use slope intercept form. Yeah, y equals mx plus b. So here we go. 3 over 2x minus 2. So I just, put my slope there, my y-intercept. And remember, in slope-intercept form, I would like to move my x to the other side of the equation. So I'm going to subtract 3 halves x from both sides. So actually, when it moves, it becomes negative 3 over 2 x plus y equals negative 2. We talked about this yesterday. There were certain qualities we look for in standard form. Is it in standard form as it is right now?
No.
No, it can't have a leading.
Negative.
It also can't have a fraction. So I need to get rid of the fraction. So here's the thing. Clearing my fractions. We talked about this back in September. Clearing fractions are not difficult to do. We can do this. So here's how I'm going to clear my fraction. Just kind of refresh your memory. I have a denominator of 2. You see that? And I don't want a denominator of 2. I also don't want the negative. So all I have to do is multiply by a negative. Remember, we did that yesterday. That gets rid of our leading negative. And also multiply by 2. So multiply both sides by negative 2. That gets rid of my denominator in the first fraction. It does so because this, when I multiply 2 over 1 times 1 over 2, those two will cancel. That's what I want to have happen. So if I cancel those out, negative times negative is positive. This is 3x, and then negative 2 times y is negative 2y. And then negative 2 times negative 2 is a positive 4. Now, is it in standard form? Yeah, it is, because I've got no leading negative, nothing starting out negative, and I have no fractions. So all I have to do is to get rid of the fraction is just use that same process we did back in September. I'm just going to clear fractions. And I'm going to clear fractions every opportunity I can. To clear a fraction, I just multiply by whatever I want to clear that's in the denominator. Or the least common multiple if I have to clear several. Let's look at another problem. Swimming pool was filling with water at a constant rate of 20 gallons per hour. What is that? When I say 20 gallons per hour, what is that called? That's a constant rate of change. Absolutely. So a constant rate of change of 300 gallons per hour. Okay, so that's 3 over 1. Don't have to write the 1 in the denominator. The pool had 50 gallons before the timer started. Okay, so let me think about what that's looking like. I'm filling this pool. If I were to put that on kind of an XY axis, okay, and it has this constant rate of change, so it has a positive slope. But when I started filling the pool, I had 50 gallons. What that's going to look like on the y-axis is something like this. If I mark these off by 10, 20, 30, 40, 50. If I'm going to graph how the pool's filling up with water, if I start out with 50 gallons, it's going to start right here, and it's going to go up, okay? Because I start out 50 gallons. What do we call this place where it starts? That's called a Y, what?
Axis.
Yeah, what happens when we cross the Y-axis? We call it a Y-intercept. Yeah. So I want you to get this. The amount of water that we started out with is actually our Y-intercept. Yes, ma'am?
Where'd you get 300?
It was in the problem. Oh, make that 200. I have no idea where I got 300. That just came from nowhere.
That's what I was thinking.
So I know you want 2 points on your quiz, right?
Yeah.
Yep, you got it. Good catch. Proud of you. Good job here. All right, so if I've got a slope, I've got a y-intercept, I use the slope-intercept form, okay? Y equals mx plus b. And then it asks for me to put it in standard form, so I just convert that to standard form. Doesn't look like I've got a lot of fractions. That's good news. Y is equal to 200. X plus 50. I need to move the 200 over, so it becomes negative 200x plus y equals 50. Can I have a leading negative in standard form? No, so I go through and reverse all the signs and I multiply by -1. So it's 200x minus y equals a negative 50. And at that point, it's in standard form. So just because it's a word problem, we can put it in standard form. We can write the equation just as easy. That's all we have to do. All right, so if you'll go to Google Classroom, you have all the information, all the tools you need to work on this assignment today. Remember, what we're after here is to take key features of that standard form of equation, use it to either graph or use the other forms that we know about to create an equation.